Okay, what we're going to do in this video is just go through the answers to this set of problems that we've got on wave speed that I set during the last class. Now, in order to do this, we're going to need three key formulas. The first one will tell us the wave period is equal to the time measured divided by the number of cycles completed. We then can calculate the frequency if we know 1 over period, and this comes from here. And then if we know the frequency, we can calculate the speed of a wave. We know the frequency and we multiply it by the wavelength. Okay, so those three formula are going to be really useful to us as we work through these questions and the other problems that we get set as we go through. So what I'm going to do is just put that over to one side. So problem one. Problem one is this pendulum question here. So problem one, we have a situation where we have a pendulum like so, and it's going backwards and forwards, and we are asked to calculate the period. So the period in this case is equal to the time that has been measured, which is calculated just here. There's 21 seconds. 21.8, sorry, 21.8, and this is divided by the number of cycles, which is just here, number 10. 10 complete back and forth cycles. So that is the cycles, and that's 10. Now what I'm going to do, obviously you can do this in your head, it's quite a simple formula, but we're going to do 21.8 divided by 10, and that gives us 2.18, and that's seconds. Period measured in seconds. So that's the first problem complete. Put an underline under that. That's our answer. Question two. Question two looks at Sears Tower, which is a large skyscraper, and the skyscraper is designed so that it wobbles backwards and forwards in the wind. So again, we have our skyscraper, and it wobbles like so between two set points. And we need to calculate the period of one wave. So again, period is time over cycles. The time in this case is here, 60 seconds, and the number of cycles is 8.6 vibrations. Very precise, but it doesn't matter too much. We can put this into what we need. So again, time is 60 seconds. Divide it by the number of cycles, which is 8.6. And again, we can always use our calculator to check our workings. So that gives us 6.98. So I'm going to round that to two decimal places, seconds, like so. Now this one asks us just here to determine the frequency as well as the period. Now, so the frequency in this case, F is equal to 1 over big T, which is the period. So we take that number, 1 divided by 6.98, and that gives us 1 divided by 6.98, and that gives us a value of 0.14 hertz, like so. Excellent. So that's question two done. So we have an answer there and an answer there. Question three. Question three is about the CD-ROM that spins, and it spins at 400 revolutions per minute. So we have a number of cycles, and we have a time period, and we're asked to calculate the frequency and the period in seconds. So let's just break this down. Firstly, we want to know the period. Period is 60 seconds divided by the number of cycles, which is 400. So again, I'm going to use our calculator. So that is 0.15 seconds. So that's the time it takes for one complete rotation to take place. And then the frequency is 1 divided by that number. So 1 divided by 0. Sorry, 1 divided by 0.15. Got there in the end. And that is 6.67 hertz. So there's our answers, like so. Question 4. This is a horrible, horrible question. Lots and lots of words. You can kind of ignore most of it because when it's talking about Earth, we're not interested in Earth. It's interested in Venus. So Venus has a period of orbit of 225 days and a period of rotation of 243 days. So the period of orbit is the time it takes to go around the sun once, okay? And the period of rotation is the time it takes for that planet to spin once on its axis. So either case, it's one cycle. The key thing about this question is it's given in days. Days are not what we use to measure time in physics. So firstly, 225 days. How many seconds is that? So what we're going to do is we're going to times it by 24, number of hours in a day, times it by 60, number of minutes in an hour, times it by 60 again, the number of seconds in a minute. So 225 times 24 times 60 times 60, and it gives us 19,440,000. And that's seconds. Now that's not the period, okay? The period in this case, is equal to the time, which is 19,440,000 divided by the number of cycles. Now what we've already said in this bit is that the number of cycles is 1. So we're going to divide that by 1, which we don't need a calculator for that, because that gives us the same number, because anything divided by 1 is the same number. Seconds. And then we want the frequency. Now the frequency is going to be 1 divided by 19,440,000. Okay, and that will give us the frequency. So 1 divided by 19,000, and it gives us a very, very small number. We can write this in standard form. So it's 5.14 times 10 to the power of minus 8 hertz. So it's a very, very low frequency. It's going around that sun really, really slowly. Now, that's the first part. The second part gets us thinking about, at this point, the period of rotation, which is 243, so question 4, days. And again, you're just applying the same principle to this. So it's that times 24 times 60 times 60. So what does that give us? That's 234 times 24 times 60 times 60. Let's get that right. 20. There we go. So it's 20,995,200. Now we're going to skip. I'm going to skip this phase because it's divided by 1. Okay. So we know that it's then going to be the so this is the period of the cycle, and then the frequency is 1 divided by 20,995,200, and then we're going to type that into our calculator. 1 divided by 20,905, and we get 4.76 times 10 to the minus 8 hertz. Okay, and then we're on to our last question. So this last question is where we bring in our final formula, and our final formula is this one. This is the one we're really, really interested in with regards to wave speed. So frequency times wavelength is speed. Okay, so we have extreme waves along ocean waters. What we're really interested in is here we have a wave. So let's draw the wave. So it's 25 meters high, that's its amplitude, and it has a wavelength of 26 meters. What else do we know about it? Assuming that these waves travel at 6.5 meters per second, we need to determine the frequency and the period of these waves. How do we do this? Well, firstly, because we know the speed of the wave and we know the length of the wave, we can calculate the frequency of the wave. So we know that V equals F lambda. Now we want to know, firstly, the frequency. F equals, in this case, velocity divided by wavelength. So in this case, we do 6.5 divided by 26. Again, we get our calculator out. 6.5 divided by 26. So that gives us 0.25 hertz. So we now have a frequency. So that's the first stage of the question done. Now we want to work out the period of the wave. So in order to do this, we're going to take this formula here and we're going to rearrange it. Okay, so I'm going to rearrange it very quickly down here in this section here. Period is equal to 1 over frequency. Okay, so if we then want to work out the period, we do 1 divided by the frequency, which is 1 over 0.25, which is coming from there. So again, 1 divided by 0.25, and this gives us a period of 4 seconds. That concludes the first 5 questions of this data set. We'll go through this one in the next video. Okay, thank you very much.